Also one example. Example here. Example. You have for 2D space the following thing, like the following straight line: y equal to x minus 3. I think we are used to this one expression at school. We were used to. And I want to define, write down, define, rewrite the given expression into canonical form of equation of the line. So remind you, we have here just two coordinates x and y, so the canonical view of the equation is the following: x minus x0 over qx equal z y minus y0 over qy. So if you manage to rewrite this one given expression into these two form, you will have the canonical view of the system of equation. It's very easy to do. So y equal to x minus 3 I can rewrite into the following thing: y plus 3 equal to x. And now I have here 2. In canonical view I have just x divided by something. So I can divide by 2, and I have 1 y plus 3 over 2 equal x. So if to make it more close to the canonical view, I can make the following thing here. The left one side about y I can leave because it's very close to the given one, and the right side is the following: x minus 0 over 1. So that means that this is the canonical view of the system, of the equation of the line. What can I say about this one expression? It means that line goes through point, I do not like P, with components 0 and minus 3, and Q has components, x component y, and y components is 2. Also one example. So I have the following one: the canonical view of the for example minus 1, the canonical view of the line. is a given line. Find a vector which is perpendicular to the given line. It's very easy to do. So the first one step, Q vector has components 2, 3, minus 1. I make here very schematically the view our situation. So for example, this is the straight line. Here we have vector Q. So the perpendicular vector, I put like n vector, normal vector, times some number here, doesn't matter. So this vector is perpendicular to the vector Q. What does it mean that n is perpendicular to the vector? Tn vector is a perpendicular to the vector Q if dot product Tn dot product Q equal 0. Let's check it. So I don't know the components of the vector Tn. I don't know, so I denote them like Tnx times 2 plus Tny times 3 minus Tn z times minus 1 equals 0. How can I calculate these numbers? I have 3 unknown variables here and only 1 equation. So I can say that there is a family of the roots for these equations, and I have to find out the parametric view of the roots. So I can take t and z like 0. It's my choice. So I have t and x times 2 plus t and y times 3 equals 0. So it means that component x of the perpendicular vector over component y equal minus 3 over 2. So if t and x equal, for example, 3, t and y equal minus 2, for example. It's my choice. So I can say that vector perpendicular to the vector q, I denote it like tn vector, has components 3, minus 2, 0. This vector is a perpendicular to the straight line vector.